Well, good morning and welcome to our first video of the day. Today we're going to talk about evaluating limits with direct substitution. And again, just as a reminder, we want you to have a notebook handy that you're going to use for calculus course next year. This should just be the start of that notebook, and we want you to kind of put everything in here in your notebook. So direct substitution is as simple as it sounds. You simply plug the x value into the function, and that's it. It's by far the easiest method of finding limits. We're literally just substituting whatever that x value is into the function. Now, the only place it gets tricky, and I guess I should say tricky, it's because of how familiar you are with your trig values. We do use a lot of trig in calc. So I just wanted to quickly go over the trig values for you. So just to recall, pi is equivalent to 180 degrees. So when I want to figure out 30, I really just do 30 degrees. I do 30 divided by 180, kill the zeros. 18 divided by 3 is 60, so this is really pi over 6. Okay, so 180 divided by 6 is 30. When I'm thinking 60 degrees, I'm doing 180 divided by 60, or really 18 divided by 6, which is 3. So this is pi over 3, just a quick conversion to radians. 180 divided by 45. When I think of 45s, that's sometimes people can't divide that easily. I just think that there's 2 45s and a 90, so there's 4 45s and a 180. So that's your pi over 4. All right, in these values, again, back when we were in school, most people were pretty good at them, had them memorized, but I'll go through them again. The sine of 30 is 1/2, and I kind of had a pattern as well as the cosine of 60. The sine of 60 is radical 3 over 2, as well as the cosine of 30. The tangent and cosine of 45 were the same. They were radical 2 over 2. The tangent of 45 was 1. We kind of said this diagonal adds up to 1. 30 for tangent has all the 3's, radical 3 over 3, and the 60 is just radical 3. So again, however it is that you memorize those, but we have to know those really well. Same with the graphs. Just to recall, so our tick marks are pi over 2 pi, 3 pi over 2, and 2 pi. Those come from the curve, from the unit circle there. And we just remember sine starts at 0 and has a nice circular pattern here. So I'm going to mark my 1s up here. So it goes 0, 1, back to 0, -1, 0. It has that hump above and a hump below. Cosine starts at its max, which is 1. So it goes 1, 0, -1, 0, 1. And again, just a nice smooth curve. And then tangent's kind of the goofball. It starts at 0 and it does opposites. So it goes 0, asymptote, 0, asymptote, 0. And it goes up on the right, everyone up on the right, and then I guess I could say down towards the left, and looks like that. Other little things you want to keep in mind, sine over cosine is another way to get your tangent function. Anyways, moving on to solving limits, but we will come back to that trig. All right, so like we said, direct substitution is the easiest method. So this says the limit as x approaches 3 for f of x, and then evaluate this. I'm literally going to substitute 3 into all the x's. Now, the only thing, obviously, you're not going to get a calculator. We want to make sure we're using parentheses, and that's going to be the key. And I'm literally just substituting 3 in with parentheses. 3 squared is really 3 times 3. So that's going to get me 9 minus 4, which is 5. This is really 11 minus 3 times 2 is 6, which is 5. So I get a final answer of 1. Direct substitution, as simple as it sounds, plug the number in and do your math correctly. We'll try the next one, number 2. The limit as x approaches -3. Remember, pause, slow down wherever you need to. So I'm going to find g of -3. Every x becomes a -3. Now again, parentheses make a huge difference. If I don't have them there, I'm likely to screw up my signs, and that's the part that we've got to get right. So g of -3, and again, I just want to reiterate, no calculator. -3 times -3 is a +9, minus a negative. So again, doing a lot of arithmetic in your head. The minus and a negative, and those two touch each other, that becomes a positive. So plus 3 minus 1. So 9 plus 3 is 12 minus 1 gets us an 11. Again, direct substitution. I just want to find f of 1. So I'm substituting and replacing all my x's with 1. 51 minus 2 times 1. Watch my parentheses. 51 minus 2 gets me 49, which of course is 7. I'll pause it, give you a minute, try the next two, and then we'll compare our answers. All right, so take a look at my work to 4 and 5. I just want to make a comment on 5. I've got 4 divided by a number, and we like to say it's all fun and games until you divide by 0. This does not exist. Okay, you cannot divide by 0. I'm going to skip 6. I think we got the hang of it, and let's move to some trig. All right, so same idea. I'm just going to substitute my pi over 6 into x. So I'm going to get the sine of pi over 6. Now again, we just have to know our trig values. The idea of calculus, the limit is very simple. We just have to know those numbers. So I'm saying pi is 180 divided by 6. 6 goes into 18 3 times. That's really 30 degrees. So the question is, what is really the sine of 30? And if you look back at your table, or hopefully get those memorized this week, the sine of 30 is 1/2. And again, it's very simple once you know those trig values. Next one, substitute 0 into x. So I've got that tangent of 0. And again, now 0 is not on my table of values, but it is on my graph. So you go back and you think of tangent at 0. Remember, they alternate. It goes 0, asymptote, 0, asymptote, 0. At 0, the tangent of 0 is 0. And that's it. Direct substitution. All right, now we haven't seen secant in a while. So the secant of pi over 2. Now that's not one of our normal trig functions. That's one of the reciprocal trig functions. So we need to remember that secant actually came from cosine. So if you can get the cosine of pi over 2, then we can get the secant by just flipping it upside down because they're reciprocals of each other. So the cosine of pi over 2, now again, that's not in the chart, that's on my graph. So if I picture so it goes 0, pi over 2, pi, etc., 3 pi over 2, 2 pi. I need cosine. So cosine starts at its max, then it hits its min. Hits its 0, then it hits its min, and continues. But right here is what I'm looking for. The cosine of pi over 2 is 0. Now that's not the answer because I want secant. 0 is really 0 divided by any number, I guess I should say. So when I flip that over to get secant, the secant of pi over 2 is now a number divided by 0. And like we said before, it's all fun and games until you try to divide by 0. This does not exist. You cannot divide by 0. So just to recap, I had to evaluate, instead of doing secant right off the bat, I did its reciprocal cosine. And then to go back to secant, I took that answer and flipped it upside down. Let's see, let's try a piecewise function. I want the limit as x approaches 6 of g of x. Now, so here's my function g of x. You'll notice 6 is the breakpoint. They always ask you the limit at the breakpoint. That's kind of the key. So I first have to say to myself, for a limit to exist, the limit as x approaches 6 from the left of f of x, or g of x in this case, has to equal the limit as x approaches 6 from the right of f of x, or again, g of x in this case. So for a limit to exist, we talked about this in the previous day, the limit from the left has to equal the limit from the right. Those have to be the same. So I do have to test both my left and my right-sided limits here. So if I want to come in from the left would be smaller than 6. That would be this function here. Okay, so I'm going to say this is 6 over 3 minus 2. 6 divided by 3 is 2. 2 minus 2 is 0. Now, is that equal to the limit from the right? So let's go ahead and test that one. Here's the limit from the right. I need, and again, they just love to throw in trig, the cosine of 6 pi. Okay, now you might be thinking, geez Louise, I don't know the cosine of 6 pi. My graph only went out to 2 pi. But remember, it's cyclical. It repeats itself. So I'm going to draw out my cosine graph one more time here with my 4 tick marks. So it went 1, 0, -1, 0, 1. There's my cosine. I don't even always draw it. I just kind of draw my points in. So here was pi over 2. Here's pi. Here's 3 pi over 2. And here's 2 pi. Now it's going to repeat itself, remember. So I want you to kind of picture this graph going out further. If this was 1 pi and this is 2 pi, where do you think 3 pi is going? Back down here. Then 4 pi, then 5 pi, then 6 pi. And it's just going to repeat that pattern out. So 6 pi is the same as what it is at 2 pi, which is equal to 1. Now, since my left side limit and my right side limit don't agree, I'm going to say this limit is not equal. Therefore, this limit does not exist. And again, pause it, rewind it, ask questions. We are here. Please ask questions. All right, so let's try the piecewise function again. We want the limit at 1. Now notice, this one got tricky. Is 1 the breakpoint? No. So if it was 0, I would have to test both the left and the right. But since it's 1, I'm just going to use this function. And I basically just need to find the ln of 1. Now, again, we don't get a calculator. And we need to know what these graphs look like. We did a lot of ln graphing last year. So if you forget, that's okay. But we'll get the hang of it. The ln of 1 looks like this. And they ask the ln of 1 a lot because that's where this crosses. So I would get this in your notebook, get it labeled for yourself. This is the ln of x. The ln of 1 is 0. It crosses at 0. So 0 is our final answer there. All right, last one to try with the piecewise functions. We're going back now. Notice this isn't a general limit. It's just the left-handed limit. So again, if it said the limit as x approaches 3, I would have to check both the left and the right. But it's just the left-handed limit, so I'm only checking the left side. So I'm looking for numbers smaller than 3, so that would be this function. So I'm going to say h of 3 from the left is equal to 3 squared minus 1. 9 minus 1 gets me an 8. So the limit from the left is 8. Now just from the heck of it, the limit from the right, we can do it in our head. 3 times 2 is 6 plus 1 is 7. Therefore, the overall limit does not exist because the left and the right were not equal. Just a little extra piece. That wasn't actually the question. So direct substitution, moral of the story, plug your number in and evaluate it.